We're now on Dcad lesson 18B, continuing with project evaluation. We had a little interlude between our 18A lesson and this one, a few other things we had to do. But anyway, we're back on project evaluation, and previously in lesson 18A we dealt with side yard setbacks and just basic lot coverage requirements and all of that, restrictions. And so we're going to continue on and deal with solar access. And in order to do that, what I've done is I've imported, drawn in the information that was on the initial site plan. That's right here is part of our initial site plan. Copy that information into a actual Dcad drawing site plan here, and also I've incorporated a larger JPEG file from the city's website. Basically indicates a map, and the reason was that I went ahead and did this was because I wanted topography at least 150 feet north of the midpoint of the north-south lot dimension I'm dealing with, which is roughly about in here somewhere. So I need to be able to have topography that's at least 150 feet north of that in order to be able to calculate what the slope is to the north for the Ashland solar setback ordinance. So along with that, I've also done a trace over of the topography and taken care of all that in there. So we have that information, and we have the existing residence and the existing garage that was done in our earlier lessons. And what we're going to do is add a second floor to this garage. So one of the things that we need to do in order to add a second floor to the garage is to make sure that we comply with the solar access requirements. And essentially this in this location, in this plot, Ashland is trying to achieve a shadow that's no higher than 6 feet at this north property line right here. So we'll see if we can get away with that or not. This could stop the project right here. It's possible that that it's just too close to the north property line to allow us to cast the shadow that we would need for a second floor. But anyway, we'll give it a shot and find out what we have. We also know that from our previous site plan, the one that we obtained from the Doe family, that our topography, our topographic intervals are at 2 feet. So, and this site is basically dropping in elevation 2 feet for each topo line that we cross toward the north. So our slope is to the north. We have our garage location right here, so we can easily measure the the eave line, which is probably going to be the highest shade producing point, to the property line to see what our actual existing setbacks are to that north property line. So in order to do that, I'm going to need to fill in some information on my solar setback calculations spreadsheet. So I'm going to open up Excel. You can use either Google Sheets for this, or Open Office, Apache Open Office spreadsheet. So I'm going to go to File, and then I'm going to click on New, and go to my templates, and go down to where I find Solar Access. And here it is, SSB. Double click, and it opens up a brand new blank solar access sheet. Now I know my job code is capital D 0604, and my clients are the Does. I can't remember their first names, but we'll take care of that later. Actually, we'll go ahead and take care of it now. All I need to do is refer to my information on my old site plan, and it's John and Jane Doe, and her address is 123 Easy Street, Ashland. Sounds like a great place. Okay, I'm going to minimize that, and so I'm just going to go ahead and enter in their names. John and Jane. Okay, and the project location will be the same. Control C, Control V. And Actually, what I'll do is just move this down to the next layer. Control X. And the same thing here. And get rid of that up there. A little cleaner. Okay, and we need to obtain the map and tax lot number. So the map number is right here, 321 East 90A. I think that'll copy and paste. Yep. And let's see what the tax lot number is. 1234. Control C and just paste it in there. Okay, so now there's some additional information on this spreadsheet we need to enter in. The first thing we want to deal with is our north-south lot dimensions, and then we'll start dealing with the slopes to the north in this area down here. Then the spreadsheet will automatically calculate stuff out. So one thing I'm going to do here is just make this a little bit smaller. I can actually get rid of this spreadsheet and make our Excel portion of it just a little bit smaller, so that way we can see things underneath. Now let me go ahead and just minimize this information here. One of the things that's important to know is that the Ashland land use ordinance is available online, just as most jurisdictions have their land use ordinances online, and so you can just click, go to the City of Ashland website, go to departments, go down to community development, click on that, and you'll see the land use ordinance right here. Click on that, and here's the various parts of the land use ordinance, and site development design standards is where the solar access portion of it is, and so you can just click on that. And then down here at 18.4.8, you can see solar access, and you can click on that, and it'll basically show you the whole solar access ordinance, how to comply with it. There's quite a bit of information there. There's additional information under definitions as far as understanding what the slope is and all of that sort of thing. So let me get back up to the drawing here. And so what I have here is the imported map from the city, and I've continued I've done the overlay of the topography, and it's at 2-foot intervals, and you can see the existing home and the existing garage on which we want to add a second floor if we can. So the first thing I need to do is to determine what the north-south lot dimension is. And so first thing I'm going to do is I'm going to just hit go to layers and just hide the image. I don't need that image right now, so I'm just going to hide it. Click OK. And so the first thing I want to do is determine what my north-south lot dimension is. So the way the ordinance reads is that it takes the southernmost point of the lot and uses that for like a baseline, and then you want to see what your property corners are on the north lot line in distance from that. So I'm going to zoom up on this, hitting Z for zoom, and I know that that the way that, this lot is configured is I'm going to hit V for vector and just right click here on that corner and just gravity move to this corner using the comma. And I can tell that up here on the Y dimension, I'll gravity move again, that is dropped minus 0.288 feet on the eastern end. So that means that that's my southernmost point of the lot. So I can hit escape, hit V for vector, and I know that my east property line, I right click on that, and my east property line is, and all I have to do is just look at the Y dimension up here in my coordinates bar, gravity move, and it is 59.9994. Okay, so I'm going to click on my spreadsheet here and just enter that in. And I'm going to put it east and go over here to 59.9994. Okay, and then next will be my west, And there are comments on this that'll tell you what to enter in if you can't remember. And so you notice it just rounded it up to 60 feet. Okay, so let me check that again. Okay, now I can still keep my point set here and just go over to my northwestern property corner and gravity move on that. And that looks like it is, again, looking at the Y distance there, distance Y, gravity move, and it is 60.2874. So I can hit escape a couple times, call it back up, and 60.2874, and that is west. And so it automatically calculates out what the average north-south lot dimension is, which is the average of these two. So that's 60.14 feet is my north-south lot dimension. Now all I need to do is figure out what my grades are. And to do that, the slope is measured 150 feet north of a midpoint through the north-south, that goes east-west, that runs through the midpoint of the north-south lot lines on the west and the east sides. So to make a long story short, I'm going to hit L for layers, and a lot of times I'll do the solar setback stuff in the 200 layers, because a lot of the stuff has sometimes to do with 3D. But in this case, I'm not going to do that. What I'm going to do is, where I had plat image, and I just used a different image line for that. What I'm going to do is I'm going to just make a new layer name for SSB. That's for solar setbacks. Corner lines. Okay. Or actually, it's SSB slope. I'll just leave it at that. Okay, and make that my current active layer. Okay, click OK. So now all I need to do, I'm going to zoom on out here a little bit using my scroll bar. And so what I'm going to do is I'm going to just draw vectors, and I want that to be red, and so it'll stands out really well. So what I'm going to do is I'm just hit Control K, just find the center point of this lot, and hit escape and hit point relative, and I want 0, then I want 150. You can see it was already entered in there, straight north. And now I come back down to around my midpoint of my lot, hit Control K, and actually sets a point there. Then go over to the east lot line and get near it and hit Control K and go to the midpoint there. And now I'm going to hit point relative again, and 150 feet is still in there, so I'm just going to hit enter. And now I can just create my somewhat of a rectangle, parallelogram actually, and right click there and hit my scroll button, and I've created my slope lines there, my slope line calculation area. So what I'm going to do now is I'm going to turn this into a dashed line, because it just makes it stand out a little bit more and easier to see. So I'm just going to zoom up on it a little bit here and take my info box and call that, actually I'll turn it to a hidden line, and I think I'll leave it at 2. That's a little bit smaller than my topo line, so it'll be easy to distinguish. Okay, so now I'm going to zoom back out so I can see that 150-foot line here, and so or box, for lack of a better term. So these are the lines on which I'm going to be measuring the slope. And so bottom line is that I'm going to be drawing some additional lines that give me an idea of where the slope points are between contour lines. It's just a really easy way to do it. So in order to do that, what I'm going to do right now is just draw a line. Actually, what I'm going to do is hit layers. I'm going to draw slope. I'll draw SSB corner lines. Okay, and I'm going to click OK, make that my current active layer. That's what I was going to do earlier, but got sidetracked. So here, I'm just going to hit V for vector, and I'm just going to leave these red because they stand out, and just right-click to this eastern, southeastern portion of our slope calc area, and just kind of come over to this line here. So I want to try to be kind of somewhat perpendicular to these lines, to the previous slope line and the next slope line. So I'm going to now I'm just going to hit K here, and you can see I have 2 points set, and hit my scroll button to initiate the vector. And now I'm going to take this and extend it, use the extend command, and go past this next slope line a little bit, and then I'm going to trim it to it using the E, that line to that line. So now I have a line that's bridging these two contour lines that also passes right through the southwest or southeast corner of my slope calculation area. And I'm going to do the same thing up here at the northeast corner. So on this one, I'm just going to, I'm going to try to get a line that's somewhat perpendicular to these two lines. Hit V for vector and right click to the corner, and something like that. Looks like it'll be fairly close. And hit K. It snaps to it. Hit my scroll button. So now I'm going to select that vector and use the extend command and extend it on out past this other contour line. Hit escape, and then I'm going to trim it to it. E. I'll show you how we use these in just a minute. Okay, so now what we have here, this one's a little bit bizarre because we actually are really close to needing an additional slope line there. Let me call up the image and see if go up here to 14, a little further, and see if we have a topo line up there. Yes, we do. We have one up here. So what I'm going to do is, real quickly, I'm going to draw another little bit of topo line up there so I can get a point between this topo line and this topo line. So I can just do a little portion of it right up in here. And to do that, I'm going to zoom up here a bit and go to layers, get my right layer to COA topo, 27, OK, and hit C for curve, and just do a quick and dirty topo line here. Just needed another one. Just clicking over this line, doing an overlay. Hit escape. Oops. Get going too fast sometimes, but hey, it happens. Just do my little overlay line. I don't need to do very much. I just need to kind of get enough to see what percentage this is. Hit scroll button, and then I want to make that the same as these other ones using the same as command, and just click on that one, and you can see that it's turned it into another topo line for me. Okay, now I can go to layers. I can hit escape, unselect that, go to layers, and go up to and hide the image again. And now I want to be back down to go back down and make SSB corner lines my current active layer, and click OK. So now I can draw a line somewhat perpendicular between these two here. So now I'm just going to hit V for vector and right click here and go up to about here. Looks pretty good. Hit K. And now I'm going to select that line that I just did and use the extend command, which is the Shift dash command. And now I'm going to trim, hit escape, and I'm going to trim this to the topo line. E, and trim to the topo line. Okay, so now I have that one set, and I'll have one additional corner line that I need to do, and that's down here at the southwest portion of our 150-foot slope calculation area. So I'm going to hit C for zoom. And you don't have to go actually perpendicular to these lines. You can just kind of go at an angle, or actually you can go even straight up. Basically, we're going to want to find out what percentage this bottom point here is of this overall 2 feet of topo line distance. So I'm just going to hit V for vector and right click to the corner there and come up to about to here. That looks about right, because I'm looking at this one also, and just hit K there, snap to that line, and hit the scroll button to initiate. Now I'm going to use the extend command again and extend on down past this line, hit escape, and then hit E for enter, or for trim, and trim to that line. So hit Control W. Now you can see I have my corner lines at all four corners. And so what that's going to allow me to do is to actually figure out what my slope is from this point to this point, my 150-foot area. That's along the east area of the property, and then on the west is the same thing. It'll be from this corner to this corner. I need to know what that total slope is, and as these are sloping to the north, they'll be minus figures, and that's really important. If you're sloping to the north, it'll be a minus figure. Okay, so what we're going to do is we're going to find out what percentage this portion of this line is of the whole thing. So this is the portion that's actually in our lot. So that's the portion that we're interested in. I'm going to zoom up to it a little bit and call up my solar setbacks and maybe make it a little bit smaller so I can see the bottom of it here, so I can see my tabs. And you can see that there's an additional tab that says Corner Slope Calcs. So I'm going to click on that, and it has the southeasterly, northeasterly, and then the southwesterly and the northwesterly corners to deal with. And it also has, when you see these little red things up in the corner here, you can click on it, just hover over it, and it'll tell you what to do. Enter negative slopes to the north as negative numbers. And you can see here what we're entering in. Contour interval slope, topo lines south to topo line north. That contour interval, it should be 2. Okay, so that distance, first of all, let me get this first. B for vector, and I'm going to right-click here and go down and gravity move to here. And that is in my distance up here in the distance box. It is 15.3196. Okay, so I'm clicking on this, and it is 15.3 96. I believe that's right, but I'll check it. 15.3196. Yes, that's correct. And then my overall topo length is 31.0686. Control C. You don't do this all the time, forget how to do it. And that shouldn't be, I'm going to hit Control V. This should not be a minus figure. Actually, the minus should be in the contour interval. Backspace there, and so this should be -2. Okay, now we're good. Okay, so now I'm going to go up to my northeasterly corner and do the same thing, and that also contour intervals will be -2 because I know it's still sloping to the north. So now I'm going to do from my topo line south to the corner. So I'm going to click up here and scroll up to there, or scoot up to there, and so my topo line south, which is this one, to the corner. So V for vector, the distance from that to the corner up here is 47.1702. You can see it right up here. Let me do it again. 47.1702. So that is 47.1702. And then my next one is the line itself. I can just hit escape and select that, and its length is 51.6125. I'm Control C to copy it. Go to my spreadsheet and paste it in. Okay, so now we know what our slopes are for the eastern lot line. And now I'm going to go ahead and, while I'm at it, just go ahead and do the western lot line. I know that's a -2 because it's still sloping there, and I might as well go ahead and enter that in my other one also, -2, where we enter in the contour intervals. Okay, so now I'm going to go over to the, actually zoom out a little bit, go over here to my southwest corner, hit escape, And in this one, I want to know, let me check what I want to know here, is I'm topo line north to the corner. So that is this topo line that's to the north down to this corner. So that distance is real simple. Vector, right click, and then gravity move. And I look up there in my D, and it's 22.6703. Right up in here, it is 22, wrong place, right there. 22.6703. 22.6703, and then go down to my next one, and that's just the distance of topo line north to topo line south. That's that distance of that line. So just click on it, and it's 28.1512. Control C, and go back here, and Control V, and so that's entered in now. And so now we're going to do the same thing at our northwest corner. So I'm going to go up here and just use my scroll bar to go on up here. And so in this case, I'm measuring from the topo line south to the corner, because that's the one that's in that area, 150-foot area parallelogram that we're calculating our slope within. So the first thing I'm going to do is hit V for vector, and it just right click from here to the corner, and gravity move to the corner, and I can see up there it is 3.729. So that is 3.729. Hit enter. And so my overall line length, hit escape a couple times and select it, and it is 49.3787. Control C to copy it to the clipboard. Go into my there and paste it. Okay, so what this tells us is, so that has entered in all of our slope points. Now the next thing we need to do is see if there's any slope points between it. So I'm hit Control W so we can take a look at all of this. So from this topographic line here, that comes on down and comes on down here, so there is one additional 2-foot step down between this corner and this corner, and on the west side, again, we have actually 2 full 2-foot drops. So that's from this corner. So that's from this topo line to here, and then from this topo line to here. So the way that works on the spreadsheet is we go back to our. I'm going to just copy this. We're going to deal with our east ones first, and I'm going to copy this, Control C, go to my calcs, and I'm going to paste it in using a number, and then I know that I have one additional 2-foot of drop, so I'm going to hit Tab and put -2. And then hit Tab again and go to my corner calcs. And so that was a southeasterly. So now we're going to go to the northeasterly one, and that's at -1.83. Control C and go to my calcs and paste that. Okay, so on the eastern grades total, slope to total in that 150 feet is -4.81 feet. So now we're going to do the same thing for the western side. The difference between the two sides is the western side actually has 2 2-foot drops before we deal with the northwest corner. So anyway, I'm going to click on this guy again and call it my corner calc. And for the southwesterly corner, we have a total of 1.61 feet. I'm going to click on that and copy it to the clipboard. And now I'm going to go to my calcs and enter that right here on the western grades, and go to right here and click that in. I'm hit Tab, and I'm going -2, and then Tab -2 again, because again we had those 2 2-foot step downs, and hit Tab one more time. And now I'm going to go here and retrieve my final corner slope, which is -0.15. And Control C, go over to here, and and paste it in and hit enter. Oops. Whoa, I shouldn't have done that. There. Okay, so now we've figured out a whole bunch of stuff here, and that is that that we're actually in lot classification B. So earlier I'd said that a city tries to achieve a 6-foot high solar fence at the north property line. That's ideal. That's for a Class A or Standard A lot. We're classified as Standard B, so that allows a 16-foot high shadow at the north property line. So I can tell you right now, I don't think that garage is going to be a problem. And on this, we'll actually plug in our actual heights, or proposed heights and proposed setbacks. But we can tell right now, at whatever that shade-producing point is, how far our setback is going to be from that north property line. So, for example, right now, if we did those eaves in the same place, and we know that we're actually these north property lines is actually pointing a little bit more to the south as we get toward the eastern end. So my potentially highest shade producing point would be this northeast corner of the garage eave. So I'm going to hit Z for zoom and zoom up on that and see how far that is from the property line. Just hit V, and that's in a north direction, true north direction. So hit V for vector and just right click on that corner and hit H for orthogonal mode. So I'm going straight north and go past it a little ways, set a point, hit the scroll button to initiate, and now I'm going to hit H to go out of orthogonal mode. You can see I've gone out of it, and I'm going to trim it to that E, trim it to that property line, and then select it and see how far that is. So the length is 24.5907. Control C. I'm going to copy that and just go ahead and plug that in there. That's my proposed solar setback, and just go ahead and plug that in. Okay, so and you can see we haven't plugged in a proposed height yet, so that's why we're getting some weird values here. But at that 24 plus feet, you can tell right here that we could be that eave could be over 19.5 feet high and not create a problem shadow. So there's no way that eave's going to be that high. So I know already that we're going to be able to comply with the solar setback aspects of the land use ordinance, and we'll take a look at the section drawing that the clients happen to have to get an idea of how high. Or actually, even the elevation drawing to get an idea of how high that eave's likely to be. But we know that the main garage floor is 8 feet. You can figure on the floor framing to be at least a foot, so that's 9 feet, and then another 8 feet for the additional floor. So that's basically 17 feet. So probably by the time we get down the grade, we might be 18 or 19 feet and high. So let's just give it a worst case scenario. Let's just call it right now a proposed height of 19 feet. And let's enter that in. And I'm going to call that the location is the north east eave. Okay, and so you can see that we're complying by height compliance of over 7 feet and a setback compliance of over 17 feet. So we're fine as far as solar setbacks are concerned, and we'll tighten that up a little bit more when we know what our exact height is at that corner of the eave. But in the meantime, we can feel comfortable now that we can comply with solar setbacks. I'm going to go ahead and save this file. And I'm going to do save as, and I'm going to put that in that project folder D0604, and I'm just going to correct its file name D0604 SSB1 save. And then later on, I'll be using this information this information, site information for you know, a little small site plan showing our slope calculation area. What is something I usually include with the solar setbacks, just so that the planning staff can see what the slope actually looks like and what I'm measuring for slope. So now that we know that we're okay with our solar setbacks for our upper floor project, we'll be in our next lesson dealing with some of the additional realities of the project, having to decide, for example, which way we're going to run our floor joists. On one hand, if we run them the short distance, which is usually the norm, those floor joists are going to be adding to the loads over that garage door header. So we might want to see if we can run those joists along the east-west direction to keep from imposing any huge additional loads on that existing garage door header. So we'll be taking a look at that and a few other things in our next lesson. This concludes Dcad lesson 18B, project evaluation. And so far so good with this project. It's a go. So far so good. We'll keep looking for things that might pop up to be a problem, but so far so good.